Hello everyone, welcome back to the channel. So in the last session we have started discussing about F block elements. There I have considered electronic configuration, that is general electronic configuration of lanthanides as well as actinides, and even we considered the different exceptions with respect to electronic configuration of those elements. Well, now in this session we are going to move on one concept of a block elements, that is atomic and ionic sizes. Okay, atomic and ionic radii, or else I can say atomic as well as ionic sizes of those F block elements. So in general we know regarding position of F block elements, where they are present below the periodic table. Okay, below the periodic table. If I consider position of a F block elements, they are present in the far below the periodic table. And how many series are there? There are two series, 4F series and 5F series. Okay, the 4F series it belongs to 6th period and 5F series belongs to 7th period of a periodic table. Means in general we know along a period what happens, atomic as well as ionic radii decreases. Okay, we know this concept. Along a period, that is from left to right, along a period in general atomic as well as ionic radii decreases. Yes, this decrease in atomic and ionic radii depends on various factors. Okay, that is one of the factor is the nuclear charge. Okay, nuclear charge. Why generally what we said atomic and ionic radii decreases? It is because from left to right, as added electron goes to the same shell. So added electron goes to same shell, but what about that is number of shells remains same. There is no change in the number of shells. Added electron goes to the same shell, but nuclear charge goes on increases. That is nuclear charge increases by unity every time. Therefore that increased nuclear charge is going to attract, okay, increased nuclear charge is going to attract valential electrons greatly. That attraction between nucleus and valential electron goes on increases, hence atomic and ionic radii decreases. Well, so if you consider even in a block, yes, it is applicable. In general, atomic and ionic radii goes on decreases from left to right across a period. So that the overall decrease in the atomic and ionic radii, okay, that overall decrease in the atomic and ionic radii from what? From lanthanum to lutetium, that is lanthanide series, there involves a lanthanide contraction. It is a unique feature in the chemistry of lanthanides. That is the properties of all lanthanides is depends on what? This decrease in the atomic radii from lanthanum to lutetium. That is called lanthanide contraction. Yes. So, however, the shielding off, we know about the shielding effect, right? Say, if we consider shielding effect of orbitals, electrons of different orbitals. So, if electron present in S subshell, they are going to show maximum shielding effect. This concept I already mentioned. Next will be the P, next comes D, and the last one comes to F. Means the F electrons have very poor shielding effect. Please remember, if the electron present in F subshell, they are going to have very poor shielding effect. If the electron present in S subshell, they are going to show maximum shielding effect. So that's what I am specifying here. The shielding of one 4F electron by another is less than 1d electron by another with increase in the nuclear charge along a series. There is a fairly regular decrease in the size with increase in the atomic number. Means in case of lanthanides what happens? As atomic number increases, there is a gradual decrease in the atomic as well as ionic radii. Okay, yes. Now if you consider that cumulative effect of contraction of lanthanide series is called lanthanide contraction. The cumulative effect of contraction of lanthanide series is called lanthanide contraction. Okay, yes. Then coming to the data regarding size. Okay, atomic number, name of the element, symbol of the element, and radii. That is, we consider atom and the most common oxidation state. that is ion. Okay, well, so they are going to show two common oxidation state, that is +4 and +3. Okay, yes. Say 57, atomic number 57, lanthanum, La is the symbol, and if you consider its atomic size is 187 picometer. Okay, Ln means it indicates the in elemental state. So atomic radii is 187 picometer. And what about ionic radii? It shows +3 oxidation state as a common, and lanthanum in +3 oxidation state, its ionic radii is 106 picometer. So 58 cerium Ce, and if you consider, okay, in +4 state there is no F electron, and its atomic radii 183 picometer, and ionic radii in +3 oxidation state it is 103 picometer. Atomic number 59, praseodymium Pr, so 4F1 configuration, and regarding atomic radii 182 picometer and ionic radii 101 picometer. Atomic number 60, neodymium Nd, 4F2, 181 picometer atomic radii, 99 picometer ionic radii. So when you look at the data here, says lanthanum to neodymium, that is as from left to right along a period, say atomic radii goes on decreases. Okay, even if you consider ionic radii values also in +3 oxidation state, yes, ionic radii also goes on decreases. Well, next atomic number 61, promethium, symbol Pm. What is the atomic radii? 181 picometer and ionic radii 98 picometer. Next atomic number 62, samarium, Sm is the symbol. What is the atomic radii? 180 picometer, ionic radii 96 picometer. Then 63, europium, atomic radii, symbol Eu, atomic radii 199 picometer, and okay, ionic radii 95 picometer. Yes. Then coming to the next one, gadolinium Gd, atomic radii 180 picometer and ionic radii 94 picometer. Then terbium Tb, 4F7, so 178 picometer is atomic radii and 92 picometer is the ionic radii. Then 66, dysprosium Dy is the symbol. Then 4F8 is the configuration. Then what about atomic radii? 177 picometer and ionic radii is 91 picometer. And coming to 67, holmium, Ho is the symbol. Okay, 176 picometer and 91 picometer atomic and ionic radii. Then atomic number 68, erbium, symbol is Er, so its atomic radii 175 picometer and ionic radii 88 picometer. Atomic number 69, thulium, Tm is the symbol, 174 picometer and 87 picometer. Atomic number 70, ytterbium, Yb. What about atomic radii? 173 picometer and ionic radii 86 picometer. The last one, okay, 71, lutetium, Lu. So lutetium, yes, when you observe all the data, what we can analyze here, say left to right, in general atomic and ionic radii goes on decreases. Okay, yes. So with this I am going to conclude about this session, that is a small part about atomic radii. Then in the next session we go for other concept. Okay, thank you, be safe.